In this video, we will introduce you to the coupling of Ansys Rocky with Ansys optiSLang. Ansys optiSLang is used in combination with design and simulation tools to automate multiphysics workflows and optimize complex designs. It does that by exploring design spaces with parametric study, optimizing designs with leading algorithms, evaluating robustness and quantifying uncertainty, and by automating and publishing multiphysics workflows. This generates valuable key benefits, such as improved product design, faster time to market, and reduced development costs. A coupled project of Ansys optiSLang with Ansys Rocky can get Rocky simulations optimized based on objectives you define in Ansys optiSLang as function of Rocky input and output variables. The workflow is quite simple. The first step consists in parameterizing Rocky inputs, such as motion frame velocity, flow rates, particle size, etc., and then defining output variables such as material wear or efficiencies, for example, for the analysis. The second step consists in going through optiSLang wizards for a guided project, depending on what analysis you want to do. In this video, we'll use Rocky Tutorial 3 as a coupled project example to optimize a vibrating screen efficiency. When setting up a Rocky project for optimization analyses, you may define the parameters you want to study as input variables. For instance, in Rocky's Tutorial 3, the initial frequency and initial amplitude are defined as variables, allowing optiSLang to recognize them as parameterizable inputs for subsequent optimization. The properties and curves will also be defined to be optimized as output variables. In this example, the curves required for calculating screen efficiency will be set as output variables. To begin the coupled project, create a folder containing both the Rocky file and Rocky.files folder. Next, open optiSLang and click on the Wizard Guided Project button. In the Solver Paradigm dialog, choose Ansys Rocky and select your project file. In the dialog that appears, select the Python file that optiSLang just generated in your project directory and click Open. Rocky will open it with a copy of your project. When asked to delete the results, accept and save your optiSLang project. At this point, your project will contain one parametric solver system, which represents your Rocky optiSLang coupled project. From the Wizards panel, drag and drop the optimization wizard onto the system to begin setting up the optimization process. This wizard allows you to define your inputs, optimization criteria, and method. For the inputs, the frequency will be varied from 10 Hz to 20 Hz, and the amplitude from 0.014 meters to 0.026 meters. In the criteria step, you can define your variables and objectives based on the output variables you selected in Rocky. In this case, we want to maximize the screen efficiency. In the optimization method step, we will keep the default one-click optimization option. By choosing this option, an internal AI selects automatically and dynamically the most suitable algorithm to optimize your case. Additionally, we will set the computation budged for the maximum number of design evaluations of 50. After going through every section of the wizard, you can run your optimization case. By default, optiSLang shows 4 post-processing result panels. History shows the evolution of the objective through different design points, that is, combinations of amplitude and frequency. Response values shows the resulting values of each Rocky output variable for the selected design point. Design parameter shows the values of Rocky input variables for the selected design point. And criteria data shows the numerical values of the variables defined in the criteria. Be sure to watch the other 3 videos in this couplings course. By integrating Ansys Rocky with other powerful Ansys software, you can make the most of multiphysics simulations.